Yes, friends, Bhuvanesh Oza, returning back to you. We are talking on different experiments which can be carried out in the engineering institutes and in diploma institutes. Uh, some of the experiments can also be carried out in training centers of industries where they are imparting training to the GETs, graduate engineer trainees, because that is a field that students do not are industry ready when they come from the institute. That itself is a big rather joke, or so to say, a big challenge to in engineering institutes, that why they cannot make the students ready for industry. And also it is the responsibility of the industries to go to the institute and tell that this is my requirement. No doubt I can very well understand that there are very many industries, and for every industries the college cannot prepare the students, but to the extent the students not knowing things now is little, I mean, it's a problem for worry for all educationists. So anyway, there is a that is diversion from my subject. My subject is giving you the experiments, not only giving you all details, giving you complete detailed circuitry, complete control circuitry, all descriptions, all method, how to do the experiment, so that you can prepare your students in the institute to be ready for the industry. That is what I am trying. And in that trial, I think I'll be giving some 15, 20 experiments. I've already given some 10 experiments, and I'll be giving 5 or uh, 10 experiments more, which I was carrying out and which I was doing at Birla Vishwakarma Mahavidyalaya, BVM Engineering College at Vallabh Ahmedabad, and in our power system laboratory we have rather uh, rigged up. We have designed 60 experiments which cannot be done in any of the institutes. I mean, it's not possible to complete those experiments in 4 years of time when experimental sessions are there. But then other experiments I was doing in extra sessions, and students were coming in those extra sessions. All those students have become CEOs or general managers or this or that, earning quite a lot big salary, and they are remembering me very well. So these experiments are done. This is not just a talk. This is things which are done at some engineering institute, right? And then are copied also in many engineering institutes. And I would request you to copy at your engineering institute. If not all, you whatever equipment you have, making use of those equipment, rig up some experiment. That will be a training for teachers. That will be a training for students. You can give some of the experiments to be designed by project students so that they can be used in the next semesters, right? Now, whatever project we are doing, they are just mm, in the corner of some institute, some room of the institute. Nobody is using. Rather than that, those projects are being used as an experiments in the next semesters. So with that intention, I'm giving you these different experiments on on power systems, power system protection, and all. I mean, on my subject of expertise. So right now we are talking on SPAJ. SPAJ 140C, it is an ABB make relay SPECOM version relay. And as I have been telling, I have been hearing from here and there that SPECOM version now they're closing. Finland factory is slowly closing SPECOM versions, and they are now, because much better relays are now available. So to be in the tune, to be with the industry, to be with the world, they have to provide better relays which can give much better facilities, and using those facilities you can protect the power system much better, much faster, much accurately, and then obviously that the fruit will be, power system will be available for more time. The darkouts, blackouts will not be there, and the obviously the electricity company will earn more. So, but then you see this relay SPAJ gives the starting. You see, rather than going to a very complicated relay, to understand a simple relay is better, and then go to a complicated relay. So, and because we had rigged up this in our laboratory, I thought that I should start with a simple relay SPAJ. And we have talked about switch groups, SGF1, SGF2, SGB, that is switch group blocking. And now we are talking on switch group relay configuration, switch group SGR1, SGR2, and SGR3. SGR1 and 2, we are talking on last switch group, SGR3, which will come an end to the relay SPAJ. And from next time onwards, from next tutorial video onwards, we will be going to power systems. Yet simpler experiment. Very simple experiment. Short transmission line, medium transmission line. Right? Simpler experiments. But I personally feel that rather than talking in theory, if you show the student the thing, you have to show the thing that yes, this is MCB, miniature circuit breaker. And see, now we are experimenting on this. We are passing current and see it is tripping. It gives a different feel rather than talking in theory. And therefore, since 1986, when I was at BVM, I am in favor of experiments rather than the theories, right? Therefore, I have taken up this experiment here in videos also. So SGR3, my friends. So what is this SGR3? SGR3 is a switch group using which you can trip two motors at a time by single relay. Right. Now you may tell that why to trip two motors, two induction motors, or two processes at a single time by a single relay, by a single breaker. Or rather, you use two breakers but give the tripping juice to both the breakers by same relay, single relay at a time, simultaneously. Such requirements are there in the industry, and therefore, you see, the relay has provided this requirement. So, to give you a simple example, in power station, there is a coal handling plant, and in coal handling plant there is a primary crusher and secondary crusher. Primary crusher crushes coal from big hips to smaller hips, smaller size, and then it goes to secondary crusher via belt conveyor. It is shown in the fill. I mean, in the figure, you can see that it is going via conveyor belt to coal storage building, and then it goes to secondary crusher. Secondary crusher crushes the coal to a very small dimension, 3/4 of an inch, some 18 millimeter of diameter, very small pieces. Those pieces are conveyed by belt conveyor once again to coal bunkers, which are near the boiler unit, right? And from there, it is pulverized. That means the coal pieces are also pulverized. It is made like a powder. The definition is 200 BS mash. BS means they are using BS standards, British standards, and that is the size of the mesh. That small pieces, small powder will come out. Powder will come out. Big powder should not come out because that small powder will burn faster in the boiler. So this is the situation in the power plant. Now you see, it so happens that because of some fault, the primary crusher closes. It becomes off. Then it does not send coal to secondary crusher. Secondary crusher goes on running unnecessarily. Then it is not receiving coal from primary crusher. Or other way around, secondary crusher becomes off. Much difficult situation. Secondary crusher becomes off because of some trouble. Right? And primary crusher keeps on working. Therefore, it will prepare a heap of coal near coal storage building. And it will be inconvenient. Then it cannot be handled by secondary crusher afterwards. Therefore, you see, if primary crusher trips, secondary crusher should trip instantaneously at a time. Or if secondary crusher trips, primary crusher, both should trip instantaneously. There can be two breakers, but both the breakers have to be controlled by a same relay at a time, simultaneously. I mean, many examples can be given. I mean, this is not the only example. You may give example when you go to the industry. Say in power plant industry, once again, FD fan and if ID fan is also a similar combination. If ID fan trips, then FD fan cannot be allowed. Otherwise, the boiler pressure will increase. Therefore, when ID fan trips, FD fan, even if it is working properly, FD fan has to be tripped. So such pairs are there. So in case of such pairs, you see, you have to trip both at a time. So SGR3 gives this facility. If you keep SGR3 oblique 1 equal to 1, the start signal I greater than is routed to TS1. TS1 is the main trip relay. One trip relay, relay A. But if SGR3 equal to 1, SGR31 equal to 0, then start signal will not reach. That we have seen. In any case, that we have that not we have seen, but if it is not, if it is 0, then it will not be routed to TS1. That means the breaker will not trip. We are not interested in that SGR31 equal to 0. But if SGR32 equal to 1, the trip signal I greater than is routed to TS1, right? If SGR32 equal to 1, the trip signal, uh, uh, there is some error in this typing. There is a typographical error, and I think you will have to correct that error, right? Because I am not correcting this. I believe that the person who is designing these things for me, I am preparing the slides, and then she must be copying. So while copying, there should not be any error, but it seems there is an error. If SGR32 equal to 1, the trip signal I greater than stage is routed to TS2, another relay B, another relay E. There is another relay E. That another relay E we have talked about, that it is available for circuit breaker failure protection. So now if you use for this purpose, you cannot use it for CBFP. That is very obvious. You can use it either for CBFP or for double trip function. So if SGR3 2 equal to 1, the trip signal of the stage I greater than is routed to TS2, second relay. Similarly, 3 equal to 0, I double greater than is routed to TS1, and 4 equal to 1, I double greater than is routed to TS2. Next relay, E, another relay. That is for 1, it is routed to this, and so here everywhere it is written TS1. So everywhere TS1 is wrong. 5 equal to 1, I0 greater than is routed to TS1. But if 6 equal to 1, I0 greater than is routed to TS2, that is relay E, another relay. Another relay means that relay controls another breaker. Relay is same, two breakers. 7 equal to 1, start signal I0 double greater than is routed to TS1, and 8 equal to 1, I0 double greater than is routed to TS2, the another relay E. So like that, the different two different relays are actuated, and when two different relays are actuated, they will give signal to two different breakers. Relay is same, and you are tripping both breakers at a time, right? Relay is same. You are not changing the relay. By same relay, you are sending the signal to different breakers. Because both the breakers are required to be tripped simultaneously, both the motors are to be required to be tripped simultaneously. Such needs are there in the industry, and to cater to such needs, the relay manufacturer is providing a facility, you see. So one has to think a lot what would be the requirement of the industry. One has to get the requirements from the industry and then design a relay accordingly, and then give the facilities in the relay. That is a difficult process of designing. Anyway, we have not to design. Design is ready. We have to use that design. So uh, please understand these design features. Why they are to be understood? Because we were understanding only that electromagnetic relay, disk type relay, that the E magnet is there and I magnet is there. Flux is produced, flux cuts the disk, therefore there are eddy currents. The interaction between flux and eddy currents produces the fork, disk rotates, the fixed contact meets the moving contact, relay operates, and therefore breaker trips. बात पूरी थी. The matter is over. Then we don't go further. I mean, we don't teach further, and therefore, you see, student learns only. I mean, in all the direction, in for differential relay, for directional relay, we are, because they have no different facilities. They have simple single tripping facility. Nothing else. Nothing else they provide. So student does not learn, and when he goes to industry, he sees that many facilities are there and many things are required, and he is told that you do this. He says that I know nothing. Then the industry understands that, oh, that student has not come by learning anything from the institute, and we will have to give them training. So they have to use their resources. They have to once again spend money. They have to build a building, training center, and in that training center they will have to have a laboratory, etc. And they will train the students for their requirement. So that is a double action, double expenditure being made. The wastage of national money. Wastage of national money because the institutes are not in line with the industry. They are not changing their syllabi. Teachers are not ready to learn new things. And teachers are not teaching new things, and therefore finally the student does not learn anything, and he learns everything in the industry. Afterwards work will be there, so he has to work. He has to work for 10, 20, 30 years. So within 1 or 2 years he will learn, and then he will become very powerful. Then he will become very powerful. Then he has to do the same work for 10, 20, 30, 40, 50 years till he retires. That is not a problem afterwards. But first or second year, he finds a lot of trouble. And many people will give him, will abuse him also. That, what are you learning? What are you doing? We are all practical people. You are all theoretical people. There is nothing like theoretical or practical. Practice comes from theory. I have not worked much in industry. I have worked hardly for 9 years in the industry. But most of the time I am in the academic institute. But because I have kept myself live, I am being able to talk like this. Therefore, my friends, I would request all the teachers and I would request all the students to learn the new things. This circuitry we have seen. This circuitry is required for testing anything, for any switch group. I will not repeat it. The control circuitry I have talked about, that also I will not repeat. The same control circuit once again I have talked about, and I will not repeat. All these things are required to talk about those switch groups, etc. Right? Therefore, I have just repeated here so that you may not have to go to the old video. They are ready-made available here. Right? So with that, my friends, uh, I come to an end of SGR3, and with that I come to an end of relay SPAJ. I have taken most of the things of relay SPAJ, SPECOM version relay SPAJ of ABB make. As I told you, now we will be taking some 4, 5, 6 experiments of some simpler kind for power system 1 level, not for protection level. Power system 1, different experiments which can be done, and by experimenting you can understand why certain practices are there and why those practices are helpful. That we have to check up experimentally. So that we'll be doing in the next experiment. Till then, as I end with one sentence, I like to end with a sentence, right? Because the sentences which are written by the saints are always beautiful. They always teach you something, and therefore, uh, as and when we get chance, we should see these sentences. The moment you accept yourself, the problem is we are not accepting ourselves as we are. We are feeling that I am knowing nothing. I am knowing less than other people. I'm other person is his face is brighter, white. My face is black. The other person is having good height. I'm having less height. So I'm not accepting myself as I am. I am as I am, and I'm best as I am, because God has made me like that. God has made me for certain purpose like that. Therefore, whatever I am is beautiful. Whatever I am been given by God, whatever I have been designed by God, I am beautiful. And once you accept that you are beautiful, you are beautiful. Other person is also beautiful. You are also beautiful. Everybody is beautiful. Everybody is beautiful in their own way, in different ways, but they are beautiful. Therefore, please accept that you are beautiful. You're fine. You're very nice. You know many things. Right? And once you know, once you accept that you know, you will start knowing. Once you do not accept, you will not know. Once you accept, you will start knowing many things. So please, friends, please remember this. With that, I request every one of you to remember Adapt Me. I have been giving many videos. I think I have given some 20 videos or so by now. I request all the friends to share to as many friends as possible. There are many things in sharing. One important thing in sharing, as far as I am concerned, is if my video is shared to many people, I will be known to many people. People will read it. If my video is uh, rather viewed by many people fully, then viewers will increase, and viewers in YouTube, you might be knowing that it means a lot. More viewers means the video is considered to be a better video, right? Then there will be more advertisements. There will be more stress on that video when that video becomes popular. So that is from my point of view. But not only from my point of view, from your point of view, as many students will know, many students will understand how the things are done. They will uh, they will rather bless you that some and such student shared me this, and I was not knowing this. I never knew this. I never knew this fact. I have been so often telling that the starter is provided in the induction motor. I so often tell in all engineering institutes when I teach, I tell to the students that starter is provided in all 415-volt small motors, not large motors. 6.6 kV motors are direct online started. But small motors, 415-volt motors in the college or in the industries, etc., they are provided as a star delta starter, or they are provided with auto transformer starter. They are provided with less voltage, right? They are not given the full voltage. The reason is while you start the induction motor, it takes about 6 times the current. Therefore, why starter is provided? The obvious answer that I get, always from all students, even from teachers, I get the answer. Same answer I get. That if 6 times the current passes through the induction motor, it will be damaged. This is the answer that people are getting. No, motor is not damaged. If 6 times the current passes for 7 seconds, motor is not damaged, because current and time has relation. Certain current motor can withstand for certain time. 6 times the current it can certainly withstand for 7 seconds. It has been so designed. It has to be so designed. So motor is not damaged. Damaging of the motor is not the purpose for providing starter. Purpose of providing the starter is altogether different. That on single line, on one transmission line or on one feeder, there are 10 industries, 15 industries. All industries are having their motors. And if, say, 4 or 5 industries start the motor at a time, then they will draw 6 times the current. And that 6 times the current will pass through main line. And main line has got its own impedance. So current multiplied by impedance, that is the voltage drop. So that voltage drop will be there. Therefore, at distribution substation, there is some voltage. Minus that voltage drop means when you come to an industry terminal, the voltage is less. And if voltage is less, the induction motor of other people who want to start will not start. Or if at all it is already started, because of under voltage, it will be damaged. Right. So to avoid that, many people should not start induction motor at a time. But board cannot tell so. That is not possible. So what electricity board will do? They will tell. I mean, you see, obviously you will have to ask for the connection. Whenever you start your industry, you will have to ask for new connection. So when you ask for new connection, they will tell that you will have to install a starter on your induction motor, and you will have to show the starter. You will have to test the starter in our presence, and then only we will release connection. Why? Because when you start your motor, the voltage is less, and therefore it draws less current. Say star delta starter draws 1/3 of the normal current, right? So 6 times the current was there. Instead of that, 1/3 of 6 times means it will draw only 2 times the current. So the voltage drop will not be an issue. Therefore, the induction motors are not started direct on line. They are started with the starter. Not because your induction motor is damaged, right? Because electricity board is not concerned with damage of your motor. Huh? તમારા પડોશીને ઘેર ચોરી થાય. If there is a theft in your neighbor's house, you are not concerned. 10 lakhs rupees are theft. Theft of 10 lakhs of rupees. But you are not worried because it is not your house. So electricity board is not concerned about the damage to your motor. Electricity board is concerned about their headache. That every now and then they will go on getting phone calls from the other industries that we are not being able to start our motor, or our motor is getting damaged. What is the reason? So that is the reason why they are asking for the starter. But in power plant, their 6.6 kV motor, 4 megawatt motor of boiler feed pump is started directly online. It takes the current some 420 amperes, right? And starting current is 4.8 times, roughly 5 times. So 400 into 5 times means about 2000 ampere it draws. Even then, no doubt, voltage drops. But motor is also not damaged, and there is no problem of voltage drop, because in power station automatic voltage regulator is there, and voltage is regulated. Voltage is brought back to normal immediately. They are very fast. Their response is very fast. Therefore, say it is in big industry, IPCL or GSFC, they are not asked to install starter, because they have got voltage, that is automatic voltage regulator facility. But in 415 volt industry, small industry, you cannot have AVR, automatic voltage regulator, because it is costly. You see, if it is an industry like GSFC or IPCL, 15 crores or 100 crores, 200 crores of rupees of investment, there you can have AVR. But an industry which has got 1 crore or 2 crore rupees of investment, they cannot have AVR. Therefore, they will have to install starter. But why starter? Everybody knows that starter is provided. Everybody knows that if starter is not provided, current will increase. That also everybody knows. That is true. Current will increase. But because the current increases, the induction motor is damaged, that is wrong. That is the wrong perception. So such wrong perceptions are there in electrical engineers' mind. Such wrong perceptions are there not only in student, such wrong perceptions are there in teachers also, and they are also teaching wrong perceptions. Therefore, you see, when an organization like ABB teaches you right perceptions, the correct perceptions, the correct rules of electrical engineering, not only electrical, ABB is for many things, not only electrical engineering, but right now we are talking about electrical engineering. Right now we are talking about power systems. When ABB is giving you so many things about power systems, you should remember the name. You should keep that name with you and tell to as many people as possible that ABB is doing this business, and ABB is rather uploading videos on YouTube. Please visit YouTube. Please see the videos. Please share the videos to as many people as possible. Please subscribe the ABB channel, right? Because you see, when somebody is giving to you, you are not paying in terms of money, but you can pay in these terms, no? And paying in these terms is not difficult. So friends, thank you for the day. Good day to everybody. Remember ADAPT me. Remember AppTrace. Thank you.